Unidos. En Estados Unidos hay observatorios nacionales, como es el NOAO, y hay otro de radioastronomía, pero este en particular es óptico. Y ella, pues, tuvo su doctorado en astronomía en la Universidad de Washington y trabaja ahora en el NOAO. Y también es gran impulsora de los aspectos de diversidad y de género. Nos va a dar una plática sobre la, bueno, ya hasta la tradujo, ¿no? Aquí dice sobre la inspiración en la ciencia y bienvenida a los científicos. Y un aplauso para la doctora Norman.
No. Quizás necesito un poco de ayuda. No sé si... No sé si... Ya, porque... Ya, pero... Está bien. Funciona. Ok. Gracias a la organización para la invitación. Y yo digo a Margarita que yo no puedo dar una charla en español. Entonces, esta charla es en inglés. Y espero que todo está bien. So, my name is Dara Norman, and I'm at the National Optical Astronomy Observatory in Tucson, Arizona. And I titled my talk today, Inspiring Science and Welcoming Scientists, because I want to talk not just about getting girls and young women interested in science, but what we do with them and how we help them once they're in the field. And so in addition to being a research scientist at NOAO, I also have the title of diversity advocate at my institution. And what that means is that I have the opportunity as part of my duties to create and advance opportunities for women and underrepresented minorities at both my institution and also to help think about how to advance them in the field of astronomy and physics. And we're looking to advance them not just in research astronomy, but also in what we call the astronomy enterprise. And this enterprise includes all of the fields that are necessary to help astronomers do their work. So things like engineering and data science and instrument building. And so what's nice about having this as my position is that I actually have time in my duties. You know, I get paid to be able to think about some of the issues that I'm going to talk to you about today. And so we're going to start with the inspiring science part. I've worked trying to help women and girls and also underrepresented minorities in the US be involved in science through various pursuits. So I've been doing outreach activities since before I was a graduate student. But as a postdoc, I had an National Science Foundation Astronomy and Astrophysics postdoctoral fellowship. And this fellowship requires the postdocs to have both an active research career, but also a project that they're doing in outreach. And so my project, and they can take that fellowship to whatever US institution they want. I took my fellowship down to La Serena, Chile, and worked at Cerro Tololo Inter-American Observatory there, which is part of NOAO. And so there I founded with a colleague in Tucson these exchanges. These are teacher development classes that we gave to have teachers in Tucson, Arizona talk to teachers in La Serena about how they discuss physics concepts with their students of various ages, mostly middle school and high school. And these lectures and these workshops were actually done over video. So the teachers and everybody had a video set up, and we actually did projects together. So in this picture, let me see if I get this right. No. There we go. So in this picture, they're actually working on building some sort of device, I think, for measuring emission lines with like these little cardboard things. But the project's being run by somebody who's a teacher in Tucson, who's done this before and is explaining how all of this works. And in this video, Father Pichete here is explaining to the teachers in Tucson a device that he made himself for measuring sort of a photometer for measuring how filters change the intensity of light. And so it was a really good exchange for teachers to share information and ideas. I've also been involved in the Astronomical Society of the Pacific's program, Project Astro. And this program is where a scientist pairs with a local teacher to mentor and engage students in the class in different projects and in discussion and demonstrations around science. And this is the class I was working with. These are some of the kids from the class that I was working with. And their teacher, Mrs. Delgado, she was actually not their science teacher. She was not even an English teacher or a math teacher. She was their English as a second language teacher. And her idea was to get the kids interested in science, and through their interest in science, they might learn English. Okay, and so in this picture, these kids were engaged in a competition where they had to build a Mars rover. So they had to learn about what Mars was like, how the rover would function on the surface, what kinds of things they had to know about how the rover would move. And here they're presenting their model and talking about what it had to do. And of course, they're doing it in English, right? So in fact, they actually won this competition. So I was very proud of them. I've also been involved with a little bit older students. Those students were 4th and 5th grade. But we have a program at NOAO that's for teenagers, sort of upper middle school and high school students, who come and they hear a lecture about some cool aspect of astronomy, right? So this is my boss, actually, and he's going to be talking pretty soon about gravitational lenses. And the really cool thing about this series is that, we as people giving the talk are encouraged to do demonstrations. So we do a lot of demonstrations during the talk. And then there's a lecture, and there's an activity period. So there's actually a workshop towards the half of it is a workshop where the students are working on some project that usually has to do with data, and so it's on the computer. But they get a project to do. But the really cool part of this activity, for one thing, it's on Saturdays. So the kids decide to spend their Saturdays sort of once a month coming and hearing this lecture. But there's peer mentoring. And so the students who have already done the talk series, they actually act as mentors and proctors for the kids who are new to the project. So they help them with the work they're doing. And so it engages all of the students both in teaching and in learning. And finally, I've also been involved in some pop culture events to get students interested in astronomy and in science. And this top picture actually shows that I've been part of a comic book series where we're trying to explain to people how surveys and big data are important to astronomy. And the way that we decided to describe that was actually through comic books, through comics. So this is actually a larger display of the comic book panels. But this was both for undergraduates and professionals, because professionals kind of like that kind of cool stuff too. And then in this lower picture, just a couple of weeks ago, I participated in an event called the Heart of Wakanda. And I don't know how many of you have seen the Black Panther movie. Yeah. But science is really important in the Black Panther movie, right? There's a meteorite that strikes Wakanda, and that's how they get the metal that makes the suit, and also is used in the throne. And so you see these hash marks here are reminiscent of the Wittgenstein patterns that you see in meteorites when you slice them. That's why this is like that. So we talked about the movie and the elements in the movie that were related to science. And so we had some meteorites here that we showed the students, and some meteorites from Africa. And the great thing about this was that it was a STEAM event. Now, usually we talk about STEM, which is science, technology, engineering, and mathematics. And when you add the A, it includes the arts, right? And so we didn't just talk about sort of the science of the movie. There was also a presentation of the culture of the movie. So things like dancing, right, which you see dances in the movie. You see fights, things like martial arts that are indigenous to the African diaspora. And there was a fashion show, actually. And so there was a way to engage students on a multiple of different levels. And so those are the kinds of things that I've done to help recruit and help inspire science. But what I really want to talk about is actually how we retain those students, right? The missing piece is the retention. Once we get students interested, how do we make sure that they can thrive in the culture that we have? Because we have a culture. We have a culture of science, right? And a culture is really just a set of values, conventions, or social practices that are indicative of a particular field or a particular group of people, right? And so, we have these shared goals and beliefs in science. We have our language, right? We have this language of equations and how we describe things. We have values. We have things that we value in science, things that allow you to get ahead. And we have things that we don't value as much, We have norms. We have established ways that you're supposed to behave when you're doing science, the ethics of doing science, things that you are supposed to do. And we have traditions. We have things that we do them just because this is the way we do them, right? And so we want to talk about some of those. And I would argue that we also have art, right? We have techniques and ways that we get our data. And there's an art to how we get our data and the methods that we use to understand our science, right? There's even an art to the way that we give lectures, right? We don't give lectures the same way to a group of professionals in our field, or a group of professionals outside our field, or to the public, right? There's an art to how you give those lectures. Some people are good at it, some people are not. And there's a couple of things about our science culture. It's different across different disciplines, right? So the culture in biology is not the same as the culture in physics, is not the same as the culture in engineering or in math. And those cultures, they're not innate, right? People don't automatically know what the culture is. It's learned. It's passed down through your advisors. It's passed down through your mentors. And so I'm going to, in the rest of this talk, look at some of that culture and how it affects us. Because it is affecting us. It's affecting how we think about science. It's affecting how we do science, right? And it's not something that we see, and it's not something that we normally measure, but we can see its effect on the people who are scientists, who are in the field. And so I have an astronomy analogy about this kind of thing. This is a picture of how we think of the universe. And this is the energy budget, the energy mass budget of the universe. And the universe is made up of basically three things. It's made up of dark energy, which is almost everything. It's nearly 75% of the mass energy budget. There's dark matter, which is actually closer to something like 24% of everything. And then there's tiny little pink sliver here, which is way too big probably in this drawing. That is everything else. It's all the baryons. It's everything that makes up this city. It's everything that you can touch and feel. It's all the atoms in the universe. And that accounts for some tiny little fraction of the energy budget. Now, this picture of what the universe is like was not something that we knew about even in my scientific lifetime. Okay? This picture is only about 20 years old, right? We haven't known this for very long. But presumably dark energy was always there, right? It didn't just appear, but we didn't know about it. We didn't feel it, we didn't understand it. And the way we came to understand it was by looking at its effects, how it affects things that we can see. So by measuring the brightness of supernovae that are very far away, finding out that they were too faint than we would have expected, we understand that something's going on. Something's happening in the universe. And in fact, what's happening is that their distance is farther away than we would have expected if we had this model. Like, we thought the model was this, but actually the model is this, right? And so the distances of those objects are farther away than we thought. And so those supernovae tend to be fainter. And so there must be something in the universe that's accelerating the expansion of the universe. All right? And we wouldn't have known about it except we looked at the things that we could see and inferred that there was an issue. There was something else going on. The same with dark matter, right? We don't know what dark matter is. We have some ideas. But we know that it exists. And we know that it exists because we can see what it does to galaxy clusters. So all these arcs here, these happen because there's a lot of mass in these clusters, these galaxy clusters, and there's more mass than you can actually see. Okay? The amount of mass doesn't account for how the light is spread out in these arcs. So again, we know there's something there, but the only way we can understand it is by looking at how it affects how it affects things that we can see. And so by analogy, the idea is that our culture, our science culture, is always there, but we can look at how it affects our scientists, and in particular, our underrepresented scientists, like women and underrepresented minorities, to understand what that culture is doing. So let's get back to the traditions and the values of science. And so in the next bit, I'm going to show you some traditions and some values that I think are not beneficial to our science culture and that are not helping us in trying to get women and minorities to stay in the field. And so I have a little picture to help you kind of conceptualize what I'm going to talk about. We have these ideas, these traditions that our science culture is built on. These traditions are things like inherent brilliance. You gotta be really smart to be able to do these things. Solitary genius. Only the best people, they get to the top by just being, the brilliant people that they are. And that allows, those two little clouds, they allow there to be bias in how we approach evaluating people, all right? And that bias then rains down on scientists in the field, and it's not surprising that there's stress. There's different kinds of stress that the people in the field experience because of these issues. And so now I'm going to talk about each of these elements. So inherent brilliance, the idea that you got to be smart to do any of these things, and that it doesn't matter how hard you work. If you're not smart enough, you're not going to make it. So there's been a study done by Leslie et al. And what they did was they surveyed scientists about, it was a large survey, and they didn't directly just ask them, do you need to be brilliant to do your work? They asked them questions around those kinds of concepts. How important is hard work to your field? How much can someone who was at a deficit, in their learning, make it up and pursue the field? And they gave a score based on the answers that people gave. A large number here indicates that the people in the field think that brilliance is very important, that it's very important to success in the field. And a low number means that brilliance is not so important, and maybe hard work and pursuing being resilient in the field is actually more important. And then they plotted that score against the percentage of US PhDs who are women in the field. Okay, so the numbers of women in the field in the US plotted against the score. And you see a pretty amazing correlation, right? For fields where there's a high degree of brilliance emphasized, not so much hard work. Hard work's only going to get you so far. It's not going to really make you. These fields have a culture that is like that, right? And fields like biology, where you see many more women pursuing, right, recognize the fact that hard work is actually very important to your success in biology. Okay, and they did this study with other fields, actually, other social science, humanities fields. And I'm not showing that plot, but it's really interesting which things. Apparently, music composition is falls on this end of the spectrum. But so, if we want to have more women in the field, then we would do well to emphasize the fact that hard work is important in how we pursue our science, right? And that we need to have a culture that doesn't just emphasize you have to be automatically brilliant to be able to do this. It also would be useful to emphasize to students that hard work is important, and maybe people who are teaching, the mentors in the field, should share personal experiences of when they had trouble, how they overcame it, and the fact that it is possible to not understand something immediately, but then to reconcile how you think about it and to move on in the field. So next we're going to go to solitary genius. Again, this is the idea that some brilliant person just did all the work and made the discovery, and they get the prize. And we all know, any of us who are scientists know, is that that's not the way science works, right? There are not just people also in your lab. There are people you talk to. There are people you bounce ideas off of. There are people who say, yeah, but did you think about this? There's a collaboratory process that happens in science. And in astronomy, it's not even just the collaboratory process. It's also all the people who went into making your discoveries, to helping you with your discoveries, the people who built the telescopes, the people who designed the instrumentation, right? The people who wrote the code so that you could do the analysis that you do. I mean, there's a lot of collaboratory effort, and we all know that. But somehow we just reward reward the one guy on top of the pedestal. And what we need to do is we need to emphasize and make clear that science is a collaboratory pursuit, and that we need to share that information, or we need to share those rewards across all of the people who actually have contributed to scientific discovery. So both of these two little clouds, they contribute to something called unconscious bias. And unconscious bias is this idea that, that non-conscious hypotheses, expectations, and stereotypes about people influence our judgments. And there have been numerous studies that have shown this to be true. Okay? And I'm only going to emphasize a couple of them that are particular, especially to women in science fields. So these studies show that, in fact, so the first study I'm going to mention is this orchestral audition study. And this is my favorite because this relies not on the eyes, not on seeing the person, but on hearing the person. So what happens when you audition for an orchestra is you come in, you sit down, you play your instrument, and the people who are judging decide, yeah, you're good enough, or no, you're not good enough to make it to the next round. Well, when they put a screen in front of the person who is actually playing, it increased the number, or it increased the number of women who got out of the first round by 50%. And I guarantee you, before the screen, everybody making the decision said, we're just picking the best players. We don't care if they're male, we don't care if they're female, we're just picking the best players. But this screen shows that, in fact, that's not true. That something else was contributing to the idea of whether these people were good enough to be in the orchestra. Okay? The next study I'm going to talk about is this study of identical applications. So what they've done is they've taken a matched set, in fact, of physics, chemistry, and biology professors, and they've sent an application for a job, a hypothetical job, and to all of these professors. Some of those professors got an application that had a male name on it, and some of them got an application that had a female name on it. And they were asked to rank who they would hire and why they would hire them, right? And what happened was, and these are male and female professors. I want to make that clear. This isn't limited to just the men. Male and female professors ranked the male applicant as higher. Mind you, these are exactly the same application except for the name. Okay? They ranked the man higher, and what's more, they ranked the woman lower because they said that they found her to be less competent. Okay? With the exact same application. All right? And this leads to things like advancement, like biases in advancement, biases in the amount of money that you make, biases in your opportunity to win prizes, all these kinds of things that we value in science. And the third thing that I want to mention are studies that show that recommendation letters for women compared to men tend to be shorter. These are recommendation letters, by the way, these are recommendation letters that will be written by somebody who knows you, right? And presumably somebody that you asked to write a letter, and so knows you pretty well and presumably likes you at least a little bit, right? But they tend to be shorter. They tend to reflect more on a person's personal life and less on their accomplishments. And they tend to have more doubt raisers, like, she's managed to do this despite having these difficulties. You know, just little comments that make the person think, well, what does that mean? You know? And so unconscious bias really affects our evaluation of people and our subjective evaluation. And those these places where we do a subjective evaluation are numerous in astronomy. or in science. And in astronomy in particular, they mean getting telescope time, getting a grant, being able to set up your lab in a particular way, all those kinds of things. So it's no wonder that with a culture that is valuing inherent brilliance, not emphasizing hard work, that is thinking of a solo actor in giving awards, not thinking of the collaboratory process. And with these rampant biases happening in the field, that there'd be a lot of stress on women and minorities in the field. And so we're going to talk a little bit about the imposter syndrome and stereotype threat. So imposter syndrome, this is the idea that you have intellectual self-doubt. So is there anybody in the room who's ever had self-doubt about the field that they're pursuing or in a class? Or I certainly have, all right? And I'll tell you my story. My story is that when I wrote my first author paper, and it got sent off for review, I got the review back, and it had very few comments of things I had to change, right? A little this here, a little that there. And I thought, well, this can't be, because I don't know what I'm doing. And so I went to the publisher who was at my university, and I said, who did you send this to? Do they actually know this field? Because I'm not convinced they do, right? And he assured me that he had been doing this for 30 years, and he sent it to somebody who was qualified to review my paper. And if that's what they said, then that's all I had to change, all right? But that's a case of imposter syndrome, right? I had this feeling that I didn't know anything. Everybody else knows so much more, right? And that wasn't the reality. The reality is I know about as much as everybody else, right? Especially in a field where I'm writing a first author paper, right? And so, it manifests itself in people attributing their accomplishments to luck rather than to their ability, being worried that somebody's going to figure out that you're a fraud, figure out that you don't know what you're doing. It's more common amongst younger people, and it's certainly very common in women because of some of these other issues that we've brought up. And it's very common in high achievers, people who have a stake in really wanting to be an expert in the field. And so some strategies to deter imposter syndrome are to acknowledge your thoughts. Everybody has these kinds of thoughts. And men have assured me that they have imposter syndrome as well, in some cases. Acknowledge them, but put them in perspective. I had to put this idea that the publisher didn't know who to send the paper to, and that's the perspective that tells me that I'm doing something wrong, not him, right? Talk to your mentors. Get people around you who can support you, who recognize your work and what you do and how well you do it. Recognize your own expertise, and you can do that by tutoring other people, doing outreach. Those are the kinds of things that solidify your knowledge. You do know things about this, and you can teach it to other people. I love this. The person who gave me this slide basically said that they keep a feel-good folder, all right, a folder of their accomplishments. So when they have imposter syndrome, they can go to this folder and say, oh yeah, I actually have done a lot of work. I'm actually pretty good at this, right? And shift your thinking from perfectionism to gaining an understanding, right? Looking at the things that you've done wrong and just trying to be better about them. And talk to someone who can help. If it's really overwhelming, try getting out and talking to somebody. So the goal is not to never feel like an imposter, because in many situations people feel like an imposter. They feel like, oh, maybe I don't know very much about this. What's different is that you have that imposter moment, but then you move on, right? You recognize that, in fact, you do know a lot. Stereotype threat. So stereotype threat is the idea that minorities in a group are conscious of and are sometimes anxious about their status as a minority in the group. They feel like they're under a microscope, right? And so they know about the stereotypes that people have about that minority. They feel the need to overcome that stereotype by being a representative of that minority. So if you have sort of one woman in a class, right, how much pressure on her is it to do well in the class if there are no other women? Because she's representing all of womanhood, right? And you can imagine that having all that pressure on you is really overwhelming, right? You can't concentrate at the task at hand if you've got all this weight on your back about representing, your group, representing your minority. It can lead to immediate and long-term health effects. You can make yourself sick over this kind of worry. And it proliferates discrimination. So it gives people who are inclined to think, oh, women can't do well. You make a mistake because you're worried about all of this stress. And they go, oh, see, we shouldn't have hired that woman. I told you what would happen, right? And you don't want those kinds of discrimination proliferation to happen. There have been many studies showing that stereotype threat is a thing, that it actually exists. And what's interesting about those studies is that, so in academic situations, they've given women math tests where matched sets of women and girls, given them math tests where they have them, in one situation, they remind them that they're a woman, and another situation they don't. And you know who does better? The people who were not reminded. And what's incredible about this is that reminding them doesn't mean getting in their faces and going, you're a woman, you're a woman, you're a woman, right? It just is checking a box. Are you male or female? Check the box. You're reminded that you're a woman. And they statistically tend to do worse. This has been done many times, and it holds up, right? But what's weird about stereotype threat is that you can stereotype people positive or negative. And so, in fact, in the US, the idea is that Asians are very good at math. And if you remind Asian women that Asians are very good at math, right, then they will tend to actually do better on the test. Statistically, in these matched sets, they'll do better on the test than someone who was just reminded that they're a woman. And this is an incredible thing. It works for other kinds of situations. Negotiations, where you tell people beforehand that men have an advantage or women have an advantage. You can get them to do better or worse on the negotiation. And it works for athletic situations where there are stereotypes. And so what are some of the things to deter stereotype threat? Well, recognizing that it's real, recognizing that there is, if you're feeling that pressure, there's a reason for it. Reminding those who are susceptible to stereotype threat of positive examples of role models. You can do it because this other person did it. And they certainly were, you're at least as good as them. Procedures that don't emphasize or remind people. So if you have to collect demographic information before a test, do it at the end of the test and not at the beginning of the test. Critical mass, this is the idea of not having one woman in the class, right? Having groups of women and groups of minorities in a class so they're not the only one and they're not feeling singled out. And acknowledgement of challenging situations. Yeah, you're feeling like this is a difficult thing to do because it is a difficult thing to do. All right, so we've got this picture of these myths that then lead to bias, that cause pressure on scientists and women and minorities are kind of the probes of that because they feel it the most. And so what do we do about it? Well, we need to get rid of that storm, right? We need a sun. Okay? And so how do we change the damaging parts of this culture that are keeping women and minorities out of the field? And some of the ways that we do that are through role models and mentoring, encouraging path, find your own path, collaboration to change the culture, and empowerment through access. So first of all, role modeling, right? We heard in the last talk about all these great women who are pursuing really important aspects of their field in order to do good and to change the way people are thinking about climate change, right? We have that in astronomy. These are all female astronomers who have done good work. And the one thing that I'll say is that we run the risk of putting these people up on a pedestal and then having the younger generation say, well, they were so amazing and I can't possibly reach that, right? So we have to be careful, a little bit careful about that. But one thing that we can do is encourage our women and girls and minorities to find their own path. You don't have to do it the same way they did it, right? You just need to find your own way to make your own mark on the field. You need to be true to yourself and understand what are the things you like to do, what are the ways that you want to pursue your science. All right? So instead of this idea of see it, but then, be something kind of similar to it. We need good mentors. And good mentors are really hard to find, I know, because I've had some terrible mentors, right? So be a good one. I've had a couple of good ones too. But be a good mentor. Encourage your students to have multiple mentors, right? Including peers. Sometimes talking to a peer, understanding that this person knows about as much as you do and they're doing just fine, that helps to improve imposter, to not have imposter syndrome. Those kinds of things. Support students in attending mentoring conferences. In the US, there are conferences like the National Society of Black Physicists meeting, or the SACNAS, the Society of Native Americans and Chicanos meeting that just met a couple of weeks ago. These are mentoring conferences. These are conferences that people go to with the idea of meeting mentors, of being encouraged to pursue math and science, and biology, in the case of SACNAS. Embrace the strategies that I've talked to you about for deterring imposter syndrome and stereotype threat, and acknowledge that there's more than one way to be a scientist or an engineer. And be aware of the culture that women and young girls are working in, right? There are pressures on people, and you need to be able to combat those pressures in order to get them to continue to be interested in the projects in the science. Scientists in the field now, including women in the field now, because I think we all probably know some women who are equally as bad as some of the men at not encouraging women. Women need to stop feeding this unwelcoming culture. Like all of us who are in the field need to stop with the expectations of brilliance and promoting like this genius mentality. And so in 2015, I and a group of friends, a group of colleagues, got together and we had a meeting called Inclusive Astronomy. And the idea of this meeting was to break down some of the barriers that are keeping women and underrepresented minorities out of the field. So we tackled these barriers on 4 themes: removing barriers to access, that is getting into graduate school or into the field, creating inclusive climates, making it more welcoming for people, establishing a community of inclusive practice, having many people supporting each other to pursue their career, and improving access to policy, power, and leadership. And the policy, power, and leadership sessions were the ones that I was particularly interested in and thought of having Because one thing that I want to do is not have us who already think this is a good idea just sitting around talking about it amongst ourselves. We need to be able to show people like us how to move into those halls of power, right? How to move up the ladder and actually change things within the culture. Inclusive astronomy was kind of a first meeting of its kind, a grassroots organized meeting. But there are a couple other ones coming up in the near future. The IAU, the International Astronomical Union, is having a meeting in Japan in November. Their website is up now. They don't have sort of the funding grants up yet, how to get those. But keep an eye on this space and think about going to this meeting for equity, diversity, and inclusion in astronomy. And there's a group that's thinking about another inclusive astronomy meeting next year at Space Telescope in Baltimore. And again, more about that soon. And so the last thing I want to talk about is empowering through access. And these are some of the talks that I've been giving recently. Because as the Deputy Associate Director for our Community Science and Data Center, I'm very interested in trying to see how big data sets, big survey data sets can empower women and minorities to be able to pursue their science. They don't need gatekeepers to let them use the telescope anymore. There's data available. They can pursue the science interests that they want if the resources are there to do it. Okay? And so the idea is that you have these data sets which allow people, this is actually the Women in Astronomy 4 conference. And those people then feed back into having really great surveys take place and really great science come out. And so if we make the resources necessary for people at small universities and under-resourced universities to be able to pursue their scientific interests because we have these data already available, right? If we make the software and the archives and all that available, we can actually improve the diversity and the inclusion of people in our field because they won't have quite as many gatekeepers as they did before. And I've written an article about this in AstroBeat, and this is the link to the article if you want to take a look at more of that. And so in summary, so what my talk has really been about has been not just inspiring women and girls to pursue science careers, but what we do when we've got them, right? When they're in the field, how do we help them move up the ladder? How do we keep them motivated and support them to do the science that they want to do? So we need to examine our science culture. We need to understand it, and we need to change the things about it that are preventing women and girls, underrepresented minorities, from pursuing these careers. And we all have to take a look at ourselves and understand, ooh, just in time. So we all have to strive to be more welcoming, to pursue a culture that is more welcoming of students and of women in our field. And so the last thing I'll just say is we need to be that sun. All right? So thank you very much for your attention.
¿Preguntas? ¿Alguien tiene alguna pregunta para la doctora Norman? Well, I want to tell you that it was very interesting and very focused about the issues we wanted to discuss here. And, well, you treat something related to employment of scientists, because perhaps you have the same number of students, which is not exactly the case, but at the time of employment, the issues you mentioned about bias and so on count a lot for not employ a woman in a scientific career. When you mentioned the impostor syndrome, well, it's not that one myself have that impression, but the others.
Yeah.
it's mostly the others that think that you are not sufficient to do something, and you need to convince yourself that you are quite capable of doing everything. And thank you very much. Another question for Dr. Norman.
Hi. I really like your talk.
Thanks.
But it's like preaching to the choir, so I have a question not related to anything you said, but about the inclusive astronomy that will be next year. Is there a topic that is going to be the focus of this meeting? Or is it going to be just a continuation of those four main ideas
so,
that the first one had?
I'm not sure. So this is the one at Space Telescope. The one at Space Telescope, I'm not sure yet. They're just starting to plan that meeting. I just got asked to be on the organizing committee. I think it's going to be a little bit different just because it's a different group of people organizing it. And so there'll be some crossover, but it won't be exactly the same. And I think the topics are not sorted out yet, but certainly keep an eye on the Space Telescope webpage because they'll certainly be advertising it as soon as they kind of decide what they want to do. Yeah.
Okay, because I think that the material that the first inclusive astronomy published at the end, like the recommendations based on the different levels of power that people have in the community, were super important and valuable for everybody.
Yeah, and so the decadal survey for the U.S. community is coming up, and this is, it'll be published in it's supposed to be published in 2020, but they're just getting started. And this is a survey of the entire field and what some of the issues are in the field, how to pursue science, what kind of science to pursue, where money goes to support that science, but also to support that workforce, right? And so right now, there are many of us engaged in writing position papers on different topics to try and influence these kinds of ideas around what the workforce needs to be, where money needs to go to support the workforce, and how we support the workforce to do the science that we want to do.
Bueno, pues démosle otro aplauso.
Well, congratulations, for your beautiful work. And I want to know if you have applied these strategies in some groups, for how long, and what are the results that you have?
Yeah, so a lot of what we're doing is, so there are many groups in astronomy who have been pursuing some of these things. So I'm trying to think of where to start. So there, I covered a lot of aspects. In my institution, for instance, we've started doing unconscious bias talks. So I'll give an unconscious bias talk before we hire someone. And so what has happened is that people are more aware of these biases. They're more aware of trying to make the pool of women larger so that there's not these, so you only have one woman, right? So we've done a lot of that kind of thing in our hiring, and it's slowly starting to lead to more women who are being hired in our institution. But we have so few people that we're able to hire at any given time. We just don't have a lot of openings. But I've seen in other places, in other organizations, at universities, where these kinds of issues are really being taken into account more, and people are thinking about it. Another thing that we're doing is we have these mission things, mission-oriented activities. We give time on telescopes, and we started talking to the panels about unconscious bias. We noticed that over time, you can see a big deficit in the number of women you would have expected to get time on the telescope compared to how many actually got time. And so we, at our institute, we're looking into doing blind evaluation of the applications for, yeah, exactly, for the proposals. The blind application. And then at Space Telescope, they actually instituted it for the first time this last cycle. And so I went to sit in on it. And so they didn't show anybody's name. And there's no information about how many women got time. But the results from having, from the panels themselves, were that they didn't have trouble evaluating. You know, everybody will tell you, well, how am I going to evaluate this if I don't know who it is? And it's just not true, right? They actually didn't have any trouble evaluating the science. A lot of people told me they thought the science was better written because people weren't relying on the fact that they were a known quantity, right? And that they actually had to write out what they were going to do and how they were going to do it. People told me that they spent more time reading the proposals because they couldn't just rely on their biases about who these people were. And, oh, they'll do good science, so let's just give them some time. So I think it was a really constructive thing to do, and we're definitely pursuing it in giving out our telescope time in the next cycles.
And at the federal level, I mean, at the government level, are there any strategies which are being applied in this direction?
So I think we're making some progress. I think we're, people have, well, not with Trump, but with people at the agencies, right? So at Inclusive Astronomy, one of the panels that I had was a panel of heads of the different agencies coming and talking about how, because I was really interested in getting the people at this meeting into positions of power. So we had people from the agencies come and talk about, you know, how you get your foot in the door to be, you know, one of the reviewers, how you sort of move up the ladder, that kind of thing. What are some of the issues with how do you write good proposals? I think it was more useful to have the panelists hear what the audience asked than necessarily the audience hearing the panel. But what happened was it got back to me from one of the NASA heads that he was glad that he had made time to attend this meeting, even though he did it remotely. And he said he would have been there in person if he had known it would be so influential, right? The head of the science group at NASA right now came into a meeting. This is a closed group. It's the Committee on Public Policy for the AAS, and I sit on that committee. And so I'm in a room. We have breakfast with the agency heads. The first thing the NASA head said to us was that he was, you know, we need to have more women proposing for these missions at NASA. We had no PIs who were women, and that is unacceptable. And I about fell off my chair because I was shocked that this had risen to be important in his mind. And so I think slowly we're making progress. Yeah, not at the very top, but sort of in the high middle range. So.
Bueno, eso es, aplaudamos a nuestra speaker y thank you very much. Nada. Y ahora